Yeah, hello. This is meeting number 11 of the Scicloj group for AI meetups. We are 9 people at the moment, and later on, maybe 1 or 2 will join. And today we'll have the special talk by Cameron, who will talk about agentic workflows and a new framework, and hopefully also about the Python aspects of that, even though it is a Clojure meetup, and about event sourcing possibly, and a few other aspects, I imagine. And so we'll hear more about all that in a moment. We begin by introducing ourselves. So each of us will say something. We have new friends today, some old friends, and so everybody will say something, who we are, what we care about, and so on. Yeah, maybe Siavash, would you like to say something about who you are?
Hi everyone, I'm Scicloj. I became familiar with Clojure, I think about 7 years ago. I built some system in Clojures, and currently I'm investigating Clara rule engines and also wanting to help Daniel in organizing in Scicloj. That's it for me.
Yeah, thanks so much. Yeah, and you should watch the old talk a few months ago by Siavash about logic programming and Clara and AI combined. So yeah, maybe Mike. Hello, Mike. Mike. Oh yeah, hello. Would you like to say something about yourself?
Sure. I'm Mike Travers. I'm a longtime Lisp and Clojure developer. I do a lot of work in scientific knowledge management and other and other applications. I've been building kind of tool to integrate kind of graph, not knowledge graphs and LLMs. I was building a framework for that, so that's something I've been working on for a while. Um, and yeah, and I'm going to another Lisp meetup today in Mountain View, California, where on where somebody else is giving a talk on a similar subject. So it's a good time for this kind of stuff.
Yeah, thanks so much. Yeah, and by the way, Mike recently gave a talk about the use of Clojure for biomedical research, and it has been recorded, so it is available on YouTube. And yeah, maybe Leandro, would you like to say something about yourself?
Hello, I'm Leandro Lactors. I'm a Clojurian based in Berlin, and happy to be in this Scicloj meeting. I've been doing different things. I've been doing the private sector and also in academia. Again, I'm happy to be part of this community. Thank you.
Yeah, thanks so much. Great to have you again with us after, a few years ago, Leandro was very much involved. And yeah, I'm Daniel. I am a Clojurian. I write Clojure, and my background is statistics and math and a little bit of geography. And today I work at Endo, which uses Clojure for scientific computing. And also I'm involved at the Scicloj group together with Siavash and others and Mike and so on. Yeah, and maybe. Oh, hello, Marlon. Marlon, so wonderful you're here with us. Would you like to say something about yourself?
So hello, good afternoon, folks. I am Marlon, and I kind of new here to Clojure community. I work at New Bank, and I'm happy to be here in this meeting, and I'd like to be more close to this community. So that's it.
Thanks so much. Yeah, it is wonderful to have you with us. Hello, Alan. Alan, would you like to say something? Oh, maybe later. Yeah. Sorry. Now we have a team. A few people together here are actually colleagues of Cameron, which is kind of nice that, we have so many new friends. And so maybe you can all say something about each of yourselves. And maybe Jason, would you like to begin and say something?
Well, I'm not with them, but I am unemployed. So if they would like me to be with them, let me know. No, I've been working with Clojure for like the last 11 years and built 2 large systems. And data science is something that is sort of newer to me, and I'm interested in and trying to learn some stuff about it. And I wanted to see what this screen thing was.
Yeah, thank you so much. Sorry for my confusion. Yeah. Hello, Daryl. Would you like to say something?
Hey, yeah. Nice meeting everyone. I am extremely green to Clojure. Since meeting Cameron, he's pulled me over to this side. Primarily background in Python. I'm the head of AI at Omni AI. My background is in data science. I made my way over to computer vision and worked in computer vision for a while. And more recently, I found myself a lot more hands-on and involved with agents and LLMs and seeing what they're capable of. And you guys will get to see some of that today. So we're excited to show it off.
Thank you so much. Yeah, and Justin K, would you like to say something?
Hey, yeah. So, I've been thinking about this all week about like how I would describe my role with Omni. I guess I'm kind of like somewhere between full stack and AI engineer. I have a background, in data science as well as biomedical like research with like using machine learning. So yeah, I only recently started using Clojure, but I have like a background in Python and I've used like C# and stuff in the past as well. But yeah.
Fantastic. Thank you so much. And Justin O, would you like to say something? Hello.
Hey, thanks everybody. I'm Justin Obney. When I called it Omni AI, I didn't realize there would be 5 of us in 10 months, and so things moved really quickly. I've been a developer for about 17 years, and this is my first go not doing the development and like handing off the reins to Cameron and the team. And my background has historically been .NET and front end and stuff like that. So now it's my job to really be on the other side, and so I'm just really interested to stay in the know, make sure I'm kind of aware of where Cameron's leading us on the tech side, and happy to contribute and help do what we can do from that perspective. And it's just awesome to kind of step back and see all the cool things that are coming out of this area. So just excited to be here.
Thank you so much. Wonderful. Yeah, I think we all spoke. Alan did say hello in the chat. So I think everybody did say something about themselves. And now Cameron will present Cameron. And Cameron will also give the talk. And we will sometimes stop Cameron with questions and comments and so on. That's okay. Great. So would you like to present yourself, say who you are and so on, and then just beginning with the talk?
Thanks, Daniel. And thanks, everybody. Good to be back at a Scicloj Meetup so soon. I'm Cameron, and I've been a professional Clojure developer since 2016. I care about the community and making sure that like there's always an option for people who want to use Clojure to do so. And so part of my personal mission is just furthering that. So just advocating for it, using it when no one can tell me not to, stuff like that. I like building cool stuff. I like building like declarative tools that help other people go fast on different kinds of problems. And for the last like almost a year now, I have been thrown into this the world of like an AI consultancy, and no one really knows what that means, including us. So we're just like exploring uncertain territory, and with that comes kind of trying to integrate the knowledge of like, okay, there's a lot of really cool stuff going on in like the Python world, and we have these like data engineers that are starting to come into existence, or AI engineers. How can we, leverage Clojure in a way that combines the best of both worlds, and maybe you end up with something that you couldn't achieve with just one or the other, and just doing that in a pragmatic way. And so that's kind of like my mission lately, which I guess segues into my presentation. So I'll start the screen share. All right, can everyone see this? Or are we good?
Yeah.
Okay. I'm still new to speaking, so like thank you for tolerating me as I figure out how I go about this. I'll be speaking a little bit longer than I did last time, and I welcome questions throughout. So if you raise your hand and start speaking, I can't see Zoom right now. So if anyone does have a question in the chat or otherwise, maybe Daniel can help steer that in my direction. Otherwise, where we're going to go with this is kind of, I felt there was a lot of interest in the sort of like Python Clojure interaction space and like how we arrived at that last time I gave this talk here. And so I'm going to focus more on those kind of details. And then there is a code demo. It's the same code demo I showed last time, and it's available online. And if we have time, I'll run through that. But this is maybe a little bit more about how we got to what we call green and sort of why we made some of the decisions we did. And so the first sort of thing that led us down this path, you can see up here, November 25th, 2024, I made this decision matrix. I had just met Daryl, who was our head of AI, and he is a Python developer, and he knows all of the best tools in the Python space for doing all sorts of AI and ML work, computer vision, and like DSPy and LLM orchestration type stuff. And so one of the first questions I had for myself as someone who obviously wants to apply Clojure, but not apply it where it's not useful, right? But apply it where it's like super useful and like and actually offers leverage, which, you know, I think is like most areas. But I think we should always ask, like, is it right when we go to use it? And so we knew that the most pragmatic choice for us was absolutely that we were going to have Python as part of our sort of lineup. But what I really wanted was, I really believe in Clojure's strength to build long-lived systems like information systems, orchestration systems, anything that like, you know, is mission critical and has to last for years and you know, be reasonable and understandable. That's the kind of stuff that I want to build with Clojure. And so the question became sort of like, how do we get Clojure and Python to work together? Because we know we're going to need both. And for anyone not familiar with the decision matrix, you just start with a question in the top left corner. Your columns are different solutions, potential solutions, and your rows are kind of like attributes. And then the green, yellow, and red is kind of like a subjective sense of how you might be weighing the particular trade-offs expressed in the actual cell. And so one good thing you can always do is take a look at, well, you can start by saying, you know, start where you're at, right? You can start where you're at and say like, okay, well, what if we just don't even solve this problem at all? And what that might look like is we just pick, you know, one language or the other, but not both. And so that would have kind of de facto put us in the world of using Python, which is like totally doable. But I really wanted to keep pursuing this idea of like, well, what if we can use Python for what it's good at in this case, which is AI tooling, and use Clojure for like the actual like, you know, the rest of the application systems that we build. And so the next like logical thing to think about was like, you know, like an RPC or HTTP kind of like basically microservices. And you can see by the red in the column here that I just like, I'm not a believer in splitting things into microservices unnecessarily. I think it adds a lot of complexity and a lot of duplication of effort, especially when it comes to like the cross-cutting concerns like logging, tracing, instrumentation. You pretty much need like a little starter template for, you know, for both kinds of systems, and they're both going to be different. They have different like debugging capabilities and profiles. Like it's much easier, and development workflows even, it's much easier to work with like systems in real time, as we know with Clojure, than with Python because of our REPL-based experience. Then sort of like the next like more tasteful option up from microservices over HTTP is like a message queue kind of pub sub event bus type of thing. A little more palatable, but ultimately you still end up with the same issue of you're like duplicating effort across your like logging and instrumentation and whatnot, and you still at the end of the day have to deal with like two different runtime systems, two different processes, the complexity that comes with being forced to have like a pub sub system. And so the last and most fun option on here was I had heard about libpython-clj. I think I learned about it like just reading like I'm not a big Scicloj tool user because I really don't know that much about data science, but it's still cool. And I think one time I was reading the sort of like what is involved and used in Scicloj tools, and I saw that there's like this Python interop thing, and one way or the other I was like, oh, well, this sounds cool. And I've actually never heard of someone like designing a system around the idea that you could combine Clojure and Python in this way in the same process. And the way I felt about it was like it is more complex in the sense that we're bringing these two environments together, but it drastically simplifies all of the other concerns like your cross-cutting issues, logging and all of that, tracing, instrumentation. You get one sort of development experience, and it's the best one. It's the REPL-driven one. You can do both Clojure and Python development at the same time. You get the best of both worlds. You can either use libpython-clj interop, or if you have Python developers on your team, or just if in some cases it's just easier to write the Python, you can just write the Python and then pull it in with a very, very thin like interop interaction. As we know, like all simple things aren't always easy, and so like it's less easy in the sense that there's no like rule book or like guidebook for this kind of thing. Like no one that I know of had really done it, or at least not advertised that they did it. And so it was kind of like we are signing up to figure out like, we'll probably have like a rougher interaction in the beginning, and we'll figure out sort of how to get these two languages and platforms like grooving together as we go. And so that's what we signed up for. We signed up to do interop with libpython-clj, and then like we began to look at everything through that lens in terms of how at the time Daryl, but now also JT and myself worked together to deliver applications for our customers that integrate AI workflows. So at our company and personally for the last like 3 or 4 years, there is a project or product design methodology called event modeling, which was created by a really cool guy named Adam Dimitrick. It's basically like the domain-driven design people like realized eventually that like no one's going to read a 1,000-page book to do DDD well. And so Adam distilled all of it down into just being able to model how information flows through a system. You don't have to use event sourcing as your underlying architecture for this, but you can. And if you do, you get a lot of benefits from it. But you can also model like conventional relational database systems with this as well. We don't. We go full event modeling and event sourcing. And so this is just an example. I'm obviously not going to have time to explain it all today, but like the white boxes are standing in for like screens or background processes. The blue ones are commands, so it's like a packaged intent to change the state of the system. So you say, I want to do X, and then you have a command handler that does some business logic validation. If everything checks out, it produces an event, which are your orange boxes. And in event sourcing, the orange boxes are all you have left if you turn the power off on the server and turn it back on, right? Like that's your data store contains events, and those are the things that have happened in the system that you're building. So command handlers produce events. The green boxes are kind of like read models or views. And so it's kind of like saying, I'm going to reduce over my events in my domain. And the green box is, what does the world look like right now? In a conventional architecture, that would be like if you work with a relational database and that's your foundational data infrastructure, you're always working with like a projection of what the world looks like now. You don't have the events anymore. But with event sourcing, you can project the current state of the world, and that's the green boxes. And so this is one of our first projects for an early customer was they wanted to be able to kind of like incrementally sync their GitHub repositories and then be able to ask questions via chatbot. So we design systems like this, and as this text here says, every command or blue box, which is a request to change the state of the system, a command can be a potential entry point for an agentic workflow. And so kind of one of our first challenges was we have this tool for designing products with our customers. How do we then bake in the fact that there can be agentic workflows in this and make sure that we're representing those while we're designing our products. And so what we learned over time was each one of these blue boxes could actually be a potential entry point for an agentic workflow. And what we've also kind of identified while wading through all of the like chaos of this space is that there's actually like a spectrum of agency. And so any one of those blue boxes or commands when we're designing a product could be anywhere on the spectrum. It could be like no agency. So you're like ordinary business logic that we've all been writing for years and years. You could have constrained agency, which is like you have a very specific task that you're trying to achieve. Like you're doing meeting transcription, diarization, and summarization, kind of like I'm sure a lot of us have seen our companies, or we've seen these AI note takers, and they just like diarize a meeting transcript and they summarize it and give you all these cool details from the meeting. That's like constrained agency because you're not really, you have a very specific task. You want to stay within like guardrails and you want it to work every time. You don't want any kind of workflow doing like open-ended stuff. Then we have less constrained, and coming up with examples for the less constrained and open-ended gets tougher because it just depends. But like less constrained might be just a chatbot whose long-term memory extends over your domain of your information system. And so like you could imagine like you have a chatbot hooked up to a CRM or something, and it's able to answer questions that were never encoded directly in the application, but it's sandboxed and it doesn't do more than it's allowed to, but within those constraints, it's allowed to do unique and interesting things. Then we have like open-ended, and that's your like coding agents or the things that you should probably be most skeptical about today. It's basically where you might still have a sandbox, but you're basically saying like, I want to do this. I don't care how you do it, as long as you have the tools to get it done. Or maybe in some cases, some people are experimenting with like, I'm not even going to sandbox you. You can choose, whatever view you want over the information system you're a part of, and just like go and do something interesting. This is where like all the agent swarm stuff comes into play. So we had to decide like, okay, given like what we're doing for our customers, what are we really trying to solve? And so we decided we're really trying to solve like constrained and to some extent less constrained, but we also wanted to make open-ended possible. And so this factors into like, what is an agent framework? Why do you even need one? And like, what should you use? And so in the beginning, we had this this Python library called Hybrid AGI, not developed by us. We knocked out a couple projects with this in Python, and we were basically, let's see, the way that we integrated it with our event sourcing framework at the time was we just called into Python, the Hybrid AGI program did some stuff, and then it would return data up to the Clojure layer, and the Clojure layer would turn that data into events where it made sense, and we would store those events. And so it was kind of like a hard line between our event sourcing framework and our like agent framework. The issue with Hybrid AGI, there's a couple. It's no longer maintained. The developer kind of moved on to like his next sort of iteration, which is similar to Hybrid AGI. It doesn't integrate in a first-class way with our event sourcing framework, which is important to us because we want our agents to not be bolted on like as an afterthought. We want them to be like first-class citizens of our domain, and this is not. The next issue is like these graph builder APIs, which is pretty much like the state of the art for like agent frameworks that everyone is building. You can see what I mean by graph builder, like that you have to like type out some stuff and then you have to like call an add function. You have to use this like builder API to make these connections between graph nodes. And I think that some people like really legitimately think this is good, and it is declarative to some extent, but you can't really follow this. Like when I look at this, it almost means nothing to me. And you can put it into an LLM and ask it to tell you about it. But like once you get down to the bottom where you're like making all these connections, it gets really confusing. And part of the issue is that you need to be able to change these things without having to like go back and understand the whole thing. And so these things are not very modular. And I think that they stem from a lack of good declarative programming facilities in these other languages. You cannot program directly with data in most languages, but you can do that in Clojure. And so I think that the graph builder thing is people trying to get like a declarative little deal, but they're not able to. Then as we were thinking about like, okay, if not hybrid AGI and not the thing that the hybrid AGI guy moved on to, then what? And we decided that like this orchestration stuff isn't rocket science. It's really like you're just like marshaling like text in and text out and structured inputs and outputs. And it looks a lot like structured programming. And we know that Clojure is very good for orchestrating stuff among a lot of other things. And so we said, okay, this agent framework thing is not really rocket science. So, we'll give ourselves permission to maybe explore like making our own. And so that's where we landed. We landed like, can we move orchestration to Clojure and use Python for what it's best at, which is the AI tools like DSPy and others, and basically the whole AI tooling ecosystem that you can get access to with Python. Because what we see here in hybrid AGI is both the tool and the orchestration combined. So this is probably, I think, using DSPy maybe, and orchestration, which is your graph builder API. And we said, can we decouple those? Can we make this more simple? Can we do the orchestration in Clojure, giving us an opportunity to fully integrate with our event sourcing framework, and then keep the Python for what it does best. And so I think I hit the streets of ChatGPT, and I was like, hey man, like, is there any other control structure than graphs, like for LLMs and stuff? And it pointed me to a paper that was, I have it linked in the slides, but it was like, behavior trees enable structured programming with LLMs. And I was like, okay, that sounds cool. And so that is ultimately where we landed for a variety of reasons. But we can see here, like, this is a very basic behavior tree. I think this comes from the demo that's available later. Behavior trees have like standard nodes that you can use, like sequence, condition, action, and fallback. These let you do basically like, and there's a couple more like parallel and retry. But behavior trees are effectively like a Turing complete control structure that generalize to like all of the other control structures that have ever been invented, since people started getting interested in structured programming, like finite state machines and like hierarchical finite state machines and whatever else. There's a bunch, and it basically one-ups them all in the sense that they are easy to understand, even when they're complex. They're optimally modular in the sense that every node in the behavior tree can actually just be another subtree, and you don't have to understand the whole tree just to move certain pieces and parts in and out. And none of the other control structures really have that property of being optimally modular. And if you were to compare, and I think one of the papers, or there's a book on behavior trees, it compares like a pretty simple finite state machine and behavior tree. And like the finite state machine looks like spaghetti, whereas the behavior tree, I have an image of one for later. It just looks like a tree and it's easy to understand. And so what we have here in ours is all of these conditions and actions are actually just like functions. So anyone can write these, and these are just ones that we wrote for the framework, like for our extensions for doing AI workflows with this behavior tree engine. And so we have declarative condition guards on the short-term memory that use Molly to check, because part of the issue with AI workflows is you want to make sure that you are getting the actual structured inputs and outputs that you want. So you want to make sure that before I even run the chat interaction, I'm checking to make sure that the user's question is in place and that the conversation history is in place. And that after I run the chat interaction, I want to make sure that the answer is actually in the short-term memory. And so this is a common pattern in behavior trees. If you read about them, is you have these kind of like these guard interactions that you can use to achieve some pretty interesting results. And so we have declarative guards over short and long-term memory. Short-term memory is just like a Clojure atom that can be reset at any time. It's like transient. And long-term memory, so if the agent wants to contribute to the domain, which is effectively its long-term memory, it will emit events into the event store. And its long-term memory that it reads when it's working is a projection of those events. So it creates a read model over those events, like the conversation history is a read model created out of a bunch of messages sent and replies sent by the agent. And then it can pass that into DSPy. So we have our magic DSPy action node. This is like a reusable thing, and you can set it up for getting some good traceability out of it. I'll get into this in a second, but we have made a little package called CLJ-DSPy that is able to generate Python code. You generally create signatures with DSPy. It's like a DSPy specific term, but the signatures are what structure your input and output, and then DSPy takes care of making sure the LLM actually sees that input structure and provides the output structure. And then you have a couple different operations you can choose from, like predict or chain of thought. Chain of thought like gives you back the agent's like reasoning string or whatever, so you can keep track of its reasoning chain. And then, yeah, like I said, you can define any custom actions. So like in this case, we defined a custom action that says, okay, we got a question, we answered the question, let's make sure we emit some events to record that so that the long-term memory can actually have the conversation history later. And so, yeah, the custom actions and conditions are like user space things. And so that's how you get more, you bend the behavior tree to your actual problem. What goes into all of this for the behavior tree setup that we have? Clojure, of course, probably the best programming language ever. Grain is our event sourcing toolkit. So it started out as just, we need to build event sourced information systems. And then it quickly became like, okay, information systems are changing like forever, and they need to be, sorry for the buzzword, but AI native, in the sense of like, okay, we're on the frontier. We're trying to figure out like what it even means to make systems that are ready for AI. Because a lot of like corporate efforts to integrate AI are failing because their legacy systems just aren't built to actually integrate well, like they're to make use of their data. And so we were like, okay, we have an event sourcing toolkit, but going forward, that has to include an agent framework so that we can build these agentic workflows for our customers. Then, of course, event sourcing. Just imagine if your information never forgets anything. And the current state of the world is always a projection of domain events. And this is not how most people do things. There's a learning curve for event sourcing. Most people work with point-in-time immutable, maybe not in the Clojure world. A lot of people work with Datomic, but most people in the world work with point-in-time mutable systems, and they're throwing information away with every interaction. And that's just not going to work, we don't think, for AI-powered systems of the future or whatever. DSPy is one of the best, most promising tools for orchestrating LLM calls. It's out of Stanford. And like I said, it really handles the inputs and outputs, and also allows you to refine your prompts over time automatically. So it can actually take you out of the driver's seat of having to do like prompt management. Once you get it right the first time, there are automatic training methods you can hook up with DSPy to where the system will actually evolve your prompts, making them more accurate over time as you annotate those interactions and say, this one was good, this one was bad. There are systems that let you actually create a feedback loop of your prompts, and DSPy will manage it after a certain point. And maybe we'll show that one day. Behavior trees, badass control structure. They originate in game development and robotics, which makes a lot of sense because you kind of have a lot of open-ended problems that you have to solve in those domains. And I'll link the slides later, but the link here just goes to that paper I mentioned. And then one thing that really makes a lot of this possible is Molly. Molly is really great in terms of a data-driven schema library that's like serializable, because we actually want our behavior trees to be serializable. This isn't strictly serializable because there are functions included in here, but I'm sure you could imagine, in the first version of this actually did use multi-methods, but I didn't want people to have to understand that just to use it. But basically, you could make this declarative behavior tree fully serializable if you want to. And we think that'll be important for the future. And so we chose a subset of Molly just so that we could, one, make it serializable, but 2, we also use Molly to create a unified schema and memory system between the Clojure part of our framework and the Python part, and I'll explain that in a second. So just like, what is Grain? Grain is structured as a polylith project, a workspace. To my knowledge, there aren't many Clojure like packages that are delivered as a polylith workspace that can be kind of sliced and diced into different sort of target packages to publish depending on, you know, what you might want to do with it. And so what we like about this is we have a simple, as in like the simple made easy kind of simple definition system of components that all work together to come together to create an event sourcing framework. And then like, let's say you're a user of it, which we're not trying to convince you to use it. We're just sharing like what we've been doing. Although you can use it. You can either pull it in as a library if you don't intend that you'd ever need to change the framework elements, or you could literally just clone the Grain repo, and then you have the entire framework at your disposal if you need to tweak any parts of it. And so we just have a lot of components that all do one job really well and create like a very quick and easy canonical way to do event sourcing, which, like I said, there's a learning curve when it comes to event sourcing because it's not in most people's wheelhouse, even though it's a better and simpler way to design information systems. And so what we really wanted was for ourselves and the community, really, for someone to be able to pick this up and like get started with event sourcing like over the weekend or something. And now that includes like agents as well. I mentioned Molly and the unified schema system a minute ago. When you have a complex agentic workflow, you're going to have multiple like calls to large language models that you need to orchestrate. And that's a lot of like inputs and outputs to manage. And you really want those things to be speaking the same language. And so we chose a subset of Molly to actually, one, generate Pydantic base models. That's what DSPy uses to do all of its typed structured input and output management with the LLM interactions. And 2, allow the Clojure and Python and just the LLM's interactions in general to speak the same language. And so you can see up here, def schemas is just a Grain. It's just a simple macro that we have in Grain that like allows a namespace, any namespace in your code to register schemas to like a central Molly schema. We use that, we take advantage of that in several parts of our system so that everything can be validated without a lot of hassle on the end user's part. But in this case, we're just registering some schemas that are going to be part of the sort of language of this hypothetical workflow below. And so we can see that we're mapping out what a conversation history looks like, what the user's question looks like. This is for like a very naive coding agent. So like, you know, is there sufficient context to answer this user's question? Do I need further clarification or can I just proceed? And here's my answer. And so the descriptions here are not just it's not just documentation for us. These actually trickle through into CLJ DSPy, which I'll explain in a second, and end up as descriptive text on Pydantic base model fields. And DSPy actually sends that descriptive text for each item in the input and output to the LLM. So the LLM actually sees these as like little hints. And then if we come down here, we can see we're defining a signature with DSPy, so build action plan in this case. With DSPy, you create a Python class and you give it a doc string. And the doc string is your primary instruction for the LLM. And then you load it up with its inputs and outputs. And you can see that I'm just directly referencing the inputs and outputs in the Molly registry. Yes, there's like a decent amount of magic going on here, but it's all in favor of keeping the sort of hassle out of this workflow once you understand it. And so this actually generates Python code, which we'll take a look at in a second. And we can see here that the inputs, this is 2 LLM interactions, build action plan and decide if context is sufficient. They both have their own like main prompt instruction. They're both speaking the same language. Both take the conversation history and the question as input. And they both have different outputs. And so they're speaking the same language. And then there's a little bit more magic here. The left side of inputs and outputs actually implicitly refers to the agent's short-term memory in the atom. And this allows our custom DSPy action node to weave together these LLM interactions. And it uses var metadata we retain this information when we actually run this macro, and it allows it to wire up and validate that the inputs are in place where they need to be, and so are the outputs, and it feeds them into and out of the different LLM interactions that we have. To take a look at the Python code that gets generated, this Python code is rough, like it's still kind of work in progress, so it probably could be better. But so we saw decide if context is sufficient on the other slide, and we saw that it takes a like a conversation history where it's a vector of maps where each map has like a role and a content key in their strings. And so we can see here that the CLJ DSPy has generated decide if context is sufficient inputs, and we have a typed list or a list of typed dictionaries where the role and content are strings, and we have that descriptive text like, hey, this is the conversation history field. We have a basic string for the question, and then we can see that like sufficient context, which is what this one produces as an output, is a Boolean, and that was declared here, so in our Molly. And then we have our descriptive text, and then we have our main doc string that we provided in the macro call as our primary instruction to DSPy. And so anytime you define a signature with CLJ DSPy, it creates this input and output Pydantic base model and then wires it together with DSPy the way it expects to. And then it's all namespace based on the Clojure namespace you ran the macro in, so you're not polluting like you don't run the risk of like collisions if you like name things the same from different namespaces and stuff like that. This is a behavior tree for like the naive coding agent. You probably can't see the text too well, but basically this is like a reentrant thing that allows you to ask a question. The model decides on the action plan. It determines if the context is sufficient to answer the question. It asks if we need to clarify. Like, do we need further clarification? And if we don't need further clarification, then we can run into this like reentrant tool user that actually goes step by step in multiple runs to determine the next step to take and which tool to run and things like that. There's actually an example of this in the macro expand demo repo, which I'll have linked in the slides, I think. I'm not going to go into it today, but suffice to say the equivalent finite state machine for this kind of thing would look like an absolute like bowl of spaghetti. And you can see here that behavior trees have a really, really clean way of allowing you to describe, a system. And I guess we'll just hop into the code demo real quick, just real fast. Let's see. Can everyone read the code, or do I need to zoom in or anything?
Yeah, that's good.
We good? We good? Okay.
Yes, good.
So let's just run through this real quick. This is like if we were to be building a full event source system, we would have like some kind of event domain. In this case, agents kind of have their own domain. Like if you have a chatbot agent, you kind of have a domain of like the user can send messages and the chatbot can reply to them. And so what's interesting that I won't get into any further, but like there's really like a composite domain idea. Like agent systems have their own domain and information system, and your customer or your company has its own domain and information system. And when you compose these two things, you get a composite domain that's more interesting than either one on its own, because the agent has that kind of indeterminism baked into it, and interesting things can happen. And when you apply that to your product domain, you start getting like the interesting things happen as a collision between the two of those. But anyway, we're defining our domain here. It's just an agent domain. So message received is when the user actually sends us something, and reply sent is when the agent responds. We can see that we're just defining the language that the workflow is going to speak. A vector of maps and role and content. This is your conversation history, your question as a string, your answer as a string. This is our main interaction. This is just a very straightforward workflow. It's just a one-shot kind of thing. So we say you're a friendly assistant, you're conversational and helpful. You take the conversation and the question, and you output an answer. And then this is our maintain conversation. So after we run through everything and get our answer, we just append some events to the event store. Message was received and the reply was sent, and we'll use that later to project the read model of the conversation history. We've already seen this, but I'll go over it briefly. A sequence node in behavior trees expects all of the children to return a success, or the behavior tree is considered either still running or failed. There are more interesting patterns that there is an example of in this repository, which is online. So we just have one sequence here, and we're going to make sure the question is in the short-term memory. We're going to make sure that if there is a conversation in the long-term memory, that it matches the shape we expect. We're going to call the chat interaction with DSPy, and we're going to make sure after that that our answer is actually in the short-term memory, and then we're going to maintain the conversation. And then before we get into the actually running the demo, this is just what the read model function looks like. It says like, hey, you know, given these events and an initial state, if you see message received, then add it to the conversation history as the role of user. And if you see reply sent, add it to the conversation history of, you know, assistant. And we'll see what a fully populated long-term memory with this read model looks like in a second. So getting down to it, we're going to define, we're going to initialize our event store. We offer, not offer, but like we've made an in-memory implementation, which is really great for quick iteration. And we also have a Postgres implementation of that follows an event store spec called dynamic consistency boundary, which is really cool, but I don't have time to explain right now. But our API is unified, and so whether you're using the in-memory or the Postgres one, it's all protocol driven, and so it's just a backend implementation detail. So it's just like a one-line change to go from like quickly iterating to using like a production grade persistent database or whatever. Then we build the behavior tree out using the behavior tree engine's build function. It takes the behavior tree from above. We supply the event store. We supply the read model function. We supply the queries it's going to run to get the events it cares about. And then we set up a context, which is really just used for the, this casually implements a textual terminal user interface, which is like a Python application, which I don't think I showed last time, and I have a second. So I literally just went and created like a UI folder in my project and asked like AI to make me like a basic terminal chatbot interface. And so this is what I mean when it's like, sometimes it's easier just to write the Python and then do like a quick integration from the Clojure side. And so I have, and all of that is shown here in the extras. If anyone wants to look at this later, it shows how the terminal UI is connected, how DSPy is connected. It even has some other stuff that's cool. So the context is just for the handler function that goes into the terminal user interface. Let me bring up this because that's where this will live. So I can say, hello there. I can say, how are you? And I can say, you know, what did I say to you first? And you said hello there, and that's because it has access to a conversation history. Now we can take a look at all of the events in the event store. So everything with our like little DSPy node is, we've made it very auditable because like part of doing this reliably for customers is you have to be able to take accountability for the stuff you build with AI. And so you need to have like a pretty robust eval framework for observability. And the first step of that is actually recording all of your interactions. And so we can see here, every time the chain of thought is used with DSPy, we can see that the grain agent reasoned. We have the inputs and we have its outputs and we have its reasoning chain. Then we have reified transactions. You don't have to think about that too hard. It's just the same as like Datomic reifies transactions. And then we have our message received and our reply sent. That's from our maintain conversation function action node that's actually emitting some new stuff to long-term memory for the agent. Then we can see the reasoning continuing. And so all of the intention is to have all of the inputs and outputs available so that you can go back and actually do that dynamic prompt training I mentioned earlier as well with DSPy. And so if we take a look at what's in the short-term memory, it'll just be whatever was from the last run. So, you know, what did I say to you first and the answer we got, and that will just be reset on the next tick of the tree. And if we take a look, if we project the long-term memory, we can see the conversation history that's being built over time with the users and assistants messages. And this is done incrementally. So it's an incremental snapshot based read model. So you're not like repopulating all of the events every time. It's actually maintaining the current state. So you only apply like the latest event that has come through, and you can build interesting read models for your agent's long-term memory. I won't get into it, but I'll just like briefly like show there's like this is what a more complex behavior tree looks like. This is the like naive coding agent. So there's like there is a sequence, but there's also a bunch of there's conditions, there's fallback patterns, there's like 1, 2, 3 or more actual LLM interactions, especially if you take into account this like soon to be very general purpose tool user. Like the tool user speaks like quite the language, and then it has several prompts that it uses to actually do its job on planning the next step, figuring out what tool to run, stuff like that. So I just wanted to show like what a more complex one looks like, because if you just look at this, you're like, oh, okay, big deal, you can do like 4 things, but this is actually the behavior tree that I showed in the slides. So like this thing. Yeah, I think that I'll call it there and see if we're ready for discussion, or if anyone has any specific questions. I'll just hand it over to Daniel generally, I think.
Thank you so much, Cameron. Yeah, and you know, the way you teach, it is just so lovely to learn from you, and I appreciate it so much that you got to talk in more than one of our meetings already, and yeah, so we have time now for questions, for discussion, and a few of us may have so much to ask. Yeah, Leandro has a comment. Is it okay to just go about the questions, Cameron, or do you wish to?
Oh, yes. And if I need to reshare, if anyone needs to see what they're asking about, just let me know and I can start the share again.
Yeah, thanks. Leandro, would you like to say something?
Yeah, sure. Thank you. Thanks, Cameron, for the presentation. It was very didactic. My question is, you mentioned the atomic several times.
Mm-hmm.
Is it because, in a way, your system could be also defined as an event-based or event-driven database, or used like that?
Yeah. So Grain has an event store component. You can see it in our repository, and it implements what is called we'll leave it at that. It implements an event store. And so our database is just events. It is just what happened, and we always project from those events the latest state of the world. The reason I mentioned Atomic is because it's not shocking to a lot of Clojure community members when I say something like that conventional approaches to relational database, kind of being your foundational information infrastructure, you're throwing away information and you're always dealing with like a mutable point in time representation of your domain. That's controversial in some circles, but not in Clojure circles. And then I also mentioned Datomic because even people who just use Datomic don't necessarily get the benefits of event sourcing. Like you could actually get the benefits with a couple changes to how you use Datomic, but most Datomic users are also throwing away the semantic information about what happened. They capture the attributes that change, but they don't capture like the name of the event. And so it leaves them in a position where they have to still try to infer what happened based on the changed attributes versus just maybe you could add like a transaction metadata that's like your event name, and then you would almost be kind of event sourcing with Datomic, with a caveat that like a lot of Datomic users I see also are still designing like kind of relationships between entities. With event sourcing, you don't have to design those relationships up front. You just capture what happened, and then you can project different shapes of how entities in your system relate. And that's useful because your transaction processing application and your agents might need different perspectives over the same data. And so rather than trying to put everything into one relational structure, and pour concrete around it, and then have to make a bunch of different kind of views, you can just start with what happened, and then all of the different elements of your system can project the view that they need over your domain. And so I mentioned Atomic because there are similarities, but then there are some subtle aspects of like, you could do all this with Datomic, but if you're not starting from the perspective of event sourcing, you're still missing some details. Hopefully that was answer your question.
Yes, thank you very much, Cameron.
Of course.
Yeah, Jason.
So behavior trees seem interesting. They seem like a kind of abstract syntax tree. Is there any way they could be more language-like?
More language-like? Yeah, so I actually got into a huge argument on LinkedIn with some like Scala guy that was like, you could have made this more concise. And I had to tell him like, you could think of what I just showed as an intermediate representation. Like I as a Clojure developer, I actually think I like the kind of wordier but very declarative and descriptive data structure approach. And so that tends to be what I lean to, instead of like a macro based system. But like anyone could come along and write a macro layer over that intermediate representation and have something that looks a lot more language like and concise, right? Like that's totally like open to possibility. You could probably do it with functions or macros. So I basically just delivered for myself and my team there the sort of middle point that gets you a lot of leverage and is like serializable and is like just a data structure, right? You could add on top of that and make it more like sugary and sweet. Is that what you mean?
Mm-hmm.
Yeah.
Yeah, thank you so much. Any more thoughts or comments or questions? Yeah, we have about 25 minutes to the official time, and then some people may like to stay longer as we usually do. And maybe I'll ask something about this Python interop part of the story. It looks like it is a general story we could learn from, and it is kind of tempting to try your method with another bridge to another Python package. And is it something you're considering? Do you wish to recommend anything to anybody who wishes to try that?
Yeah. Okay. So my opinion on the whole Python interop thing. So like I get excited anytime I see Clojure's reach extend further, because it just means like I can do one more thing in one more platform that someone else on that platform can't do in the reverse, right? For the most part. And so when I see things like Clojure Dart, Jank, Clojure Script, Babashka, like all of the things, I'm just like, look how far my reach extends. And so we also have Python reach, and I wasn't aware of it until recently. And I think that most people aren't super aware that you can just get the best of Python right in Clojure. And so there's multiple ways to look at it. One is the sort of like, our shared philosophy of like, we interop with Java, and so we don't always have to build something from scratch. We can actually just do direct interop to use some Java packages. Or we could write a wrapper if we want to, but we don't even have to do that. And so like, if you're not trying to impress any Python programmers and you're just trying to like get stuff done, then you could just go for the direct interop and solve your problem, right, with a Python package that can solve it. If you are trying to impress the Python people and you want them to feel comfortable and at home, then I think Clojure really starts to shine because you can build some macros that allow you to take a Python experience that someone is used to and try to model it as closely as possible while also introducing some of Clojure's strengths into the workflow so that one, they feel comfortable when they're looking at it, and two, they're also experiencing benefits that they wouldn't have gotten just with Clojure. So like with our DSPy stuff, it writes the Python that you would need to write for your DSPy signature, and it evaluates it for you. And so unlike in a Python workflow where you kind of have to like rerun the thing, save and rerun, and the REPL experience isn't great, you can just save on eval or eval on save in your Clojure environment and just be like iterating really fast, even though you're doing DSPy and Python development behind the scenes. That's the kind of thing that the Python programmer wouldn't have if they hadn't tried the sort of like little magic macro layer. And then it also gives you the opportunity then to sort of like put Clojure in as the canonical control structure, because you also have this escape hatch, right? You have making it comfortable for the Python programmer. You have, they can still write Python if they need to, and then just go back to that basic interop interaction and make the call into Python. So I think there's different perspectives you can take, whether it's like, I'm just trying to solve a problem, or I'm trying to solve a problem and make it ergonomic for someone coming in. And DSPy was just one example. I was like, once I understood it, I was like, oh, okay, I could like just generate the Python for that. And then have this like unified schema language. I don't know any other packages that we would try that on yet, but it's interesting to think about building those bridges to not try to come up with something like so bespoke, but try to come up with something that's comfortable but powerful, right?
Yeah, thank you so much. Mike.
Yeah, this is a good follow-up to that question. So I don't know DSPy at all, but I've looked at a few other, Python, agent libraries, and they all seem pretty thin to me. And I look at them and I say, well, I could just re-implement most of this in Clojure pretty easily. Maybe use some of their prompts or something like that. So I guess I guess the question is, did you think about what does using DSPy buy you versus, let's say, doing everything in Clojure? And did you think about that alternative?
Totally. Daryl, are you here still?
Yeah, I'm still here. I was gonna say I could speak to that if you want.
Yeah, give us a rundown on DSPy and yeah, speak to whatever part of that you'd like to.
Yeah, absolutely. Yeah, so I totally agree. Agent orchestration things are super thin. Most of the time they're gross. If you've messed with LangChain or any of the really popular ones, like Pydantic AI or what's else, like Agno or those like that, it's basically just like we want to take away all of your ability to do these things with LLMs, and we're just going to like abstract it for you, and then just like you're going to have to hope that we built it really well and just trust us, right? And the interesting thing about DSPy is it's not trying to orchestrate for you. All it's doing is managing the parts of the orchestration that you would kind of expect to orchestrate, which is just the input and the output to the LLM. Like that's all I care about. And of course, with structured output, you can just do that with the direct, like talking to the model. That's not that difficult. It's nice that DSPy has the Pydantic type checking to be able to make sure that you're getting the structured output. The extra leverage you kind of get from DSPy is there's a fallback JSON mode for any LLMs, because there's plenty of very small LLMs out there that don't have structured outputs by default. And the way that DSPy uses the prompt compiler in the background, it makes it possible to make outputs from LLMs structured and parsed, even though they don't have structured output as an option, which is really nice. But the real engine of DSPy that you get the use out of is the Stanford research behind the actual prompt optimizers. So under the hood, you have the actual prompt optimizer that's taking the structured input, baking it into a system prompt that's really structured and really good and has good descriptions. It sort of like analyzes the intent behind what you're trying to do using the semantic meaning of the tags. And then it builds a really good and robust user message that instructs the LLM exactly how it's going to structure its response and things like that. And then the LLM gives its answer back in a way that DSPy understands it and then can actually parse it even if it's not structured output. And then that prompt optimizer has lots of really great algorithms built behind it, like CoPro, MyPro, and things like that, where you essentially have these student and teacher LLMs that can learn from each other. They can instruct each other. They're trying to figure out what prompts are better. If it gets better, it does this continuous hill climb to see, if it got better, why did it get better? If it got worse, why did it get worse? Reasons about that to continuously improve your system.
Thanks, Daryl. And so hopefully that, Justin?
Yeah, I think at a high level, what that is DSPy is constantly evolving and making the actual LLM interactions dramatically better and constantly dropping new algorithms to do that as well. And that expands all the way from pure optimization algorithms built in with no AI to optimizations that use AI for the prompt optimization itself. as well as during inference, it has algorithms that both use the current data that you're tracking to build better prompts at runtime, and they're constantly updating that. And so you get that full spectrum of constantly updatable things with only having to drop down to, can we describe the intent through these Mali schemas that become DSPy signatures, and everything below that just becomes this DSPy, declarative self-improving Python. And so, you know, the AI engineer no longer thinks I write the best prompts. They're like, no, that system writes the best prompts.
Yeah, and just to take all of that and to finalize the answer, yes, we could build anything in Clojure, right? I think that's pretty clear that we can build just about anything in any language. And so it really comes down to, like, should I in this case? And I think that comes down to our sort of shared value system in Clojure of being pragmatic over anything else. And so just like we have access to 100,000, you know, Java packages, and we or more, like, you know, millions probably, we don't need to reinvent the wheel when a good wheel already exists. We can just call right into that wheel. And so it's the same thing with Python in this case, because DSPy stands apart. It's driven by Stanford research. It stands apart from those other tools because we're also super skeptical of those other tools and orchestration frameworks. And so we said, you know, what's the best, like, cornerstone that we can bake into just any LLM interaction that we have? Let's use that from Python because that's the best wheel. And then we'll take over the orchestration because, as you identified and as we identified, orchestration is not rocket science, and you can do any of that in Clojure, and you can probably do it better than you could do in Python or in TypeScript or whatever. So hopefully that answers your question.
Yeah, thanks. That was a very useful answer. Thank you.
Nice.
Yeah, fantastic. We have 15 minutes to the official time where some people may need to leave. And today we're kind of lucky to have a whole team with us. And it is, you know, this special occasion. So maybe if anybody of the team wishes to add anything, you know, with your voice, with your perspective of this project, then it would be kind of nice to hear you as a team. Would it make sense to, you know, spend a few minutes with the team?
Sure.
Yeah, I mean, I'll just say that Cameron has been trying to get me to use Clojure for a number of years. I, like, far before we were working together, he was pushing this. I actually met Cameron through a buddy of mine that I work with, that I would walk by and see kind of him reading the Clojure books and stuff like that. And that thing that kept bumping into my head was the code is data, data is code. And so around that time, a couple years ago, I saw a guy, Ryan Robitaille, building these really cool things in Clojure. And I really got to see the effect of that boundary kind of erasing. And that's really what gave me a lot of excitement, and, like, was like, cool, Cameron, let's do it in Clojure. When I started seeing all the AI aspects of both, okay, we're going to be writing code that goes to a thing that can generate code that we might want to execute that code, and having that loop where you can kind of verify that code that just got generated really easily and continue down that path of the intent, was, from an outsider as not a Clojurian, what kind of gave me, like, okay, I can see where that really could be useful. And that was what helped me be like, cool, y'all go that direction and I'm on board. And so that, I just figured I'd share that from my perspective of why I think that's appealing from not a pure Clojure developer perspective.
I should point out that the buddy that Justin is talking about is none other than Brandon Renge, Calva maintainer. So
Daryl, Justin, JT, y'all have been in Clojure, what, 2 or 3 months now? Y'all got any thoughts?
Yeah, I got my toes dipped in it. I definitely, so Cameron's, like, fully bought me in. Like, I saw the strength of Clojure, and coming from purely Python, there was sort of like these hidden weaknesses that I didn't realize I had until I saw Clojure. So there was a lot of things, like, especially with the agents, whenever you try to orchestrate what they're doing and, like, how they're managing their memories and stuff like that, that is just, like, pure weakness in Python. Like, you have to manage the state, which is like an object that you have to parse with its own methods, which is just standard, just object-oriented mess. And then like, managing their memory and managing the conversation and all of those things, it's really, really messy in Python. But where Python sort of does its best work is where I can actually just train a model or load up a model or things like that. Like I want to train a computer vision model in Python. I want to use a computer vision model in Python, but I want all of everything that I'm translating about that computer vision model to be happening through Clojure at this point. So it's been great seeing that interaction and actually seeing like the light in this data tunnel that Python just could not handle before.
Yeah, I think my biggest thing, and this is just like kind of a small thing, but I guess like in getting like developing Clojure in the REPL and then going back to Python, it kind of pisses me off to not like have the REPL, you know?
That's a common feeling. I guess I want to highlight something because I've been thinking about this a lot, especially since the last session where we kind of got into a lot of people are always like, how do I convince, user of XYZ language that Clojure is better? And I've just been thinking about this lately, and I think that we kind of have to, and this is my opinion, we have to accept that, like I said earlier, you can probably build just about anything in any language these days, as long as it's like a general purpose use case or whatever, and it's a general purpose language. And so I think that trying to pretend that we can objectively convince someone else that Clojure is just objectively better than what they use is probably never going to work, because whether people want to accept it or not, I think a lot of people tend to argue their personal preferences as like objective fact when it comes to programming languages. And I think that what we're all actually should be saying is like, no, it's okay to have a preference. I prefer Clojure. I'm biased towards Clojure, and someone else might prefer Scala or Python or whatever. And I think that what we actually need to focus on is like I've never heard like a Python developer say, I love Python so much that I, wouldn't want to be a developer anymore if I couldn't use Python anymore. But you can ask a lot of people in the Clojure community and they'll give you some kind of answer like that. And it's kind of weird that we like have like a spiritual experience almost with this programming language. And so I think what we should focus on is like guiding people. Like if you've never tasted sugar, then you can't really describe like what sugar actually tastes like to someone. So it's like, how can we guide people to make them walk into this moment where they like experience how good of a workflow and a platform Clojure actually is, so that then they too are like, holy crap, this is awesome. And it's not like trying to weigh some objective metric about programming languages that doesn't really exist. I think that's just something I've been thinking about. It's like, how do we guide people and then also show them that like we're not just hitting you over the head with this, like it's actually innovative and better in terms of your workflow once you see it. You just have to experience it and get past like the parentheses and stuff, right? I don't know if anyone has thoughts on that.
Yeah, I think it means so much to hear this story and to hear your voices, telling this story. And probably all of us in any project will run into this situation where we need good people to work with who have good wisdom and experience and sometimes specialized knowledge. And we may find those people who happen to write Python, and we want them to work with us, and we want to have them comfortable with us till they may like to write our own language, right? That will happen all the time, right? And so we need experiences like that.
And just to speak again from like an empowering piece, I got hooked in AI 2 years ago teaching my daughter how to read, and like I see it as just a massive accessibility tool more than anything that's bridging communication gaps. And so it gives me a lot more confidence, like once we have our stuff set up, that I can use things like Claude Code to really execute a lot of my intent. And then being able to do that on top of some subsystem that already has a lot of flex, that I don't have to like lose flexibility by choosing a more rigid subsystem, but I can still kind of engage in it. The behavior tree is a great example of that, because I can look at that, understand that at that level very easily without having to worry a whole bunch about it, and then just make subtle changes that obviously need verification, but really start getting a lot more action and not have to be worried about, is the thing I'm trying to do overly complex in the language and the tools, given that I'm kind of just using this other tool like Claude or something like that to try to execute that intention.
Right. And that kind of gets into system design and choices, because like so I showed event modeling earlier. Grain, and this is kind of subtle, so it may be hard to actually visualize. But like Grain, when you build with Grain, you're actually building what the event model looks like, and we did that on purpose. And then with the agent framework, you're building behavior trees, and the design choices in the actual like units of work that a developer does in our system enforce an actual simplicity on the end result. And so the blast radius for complexity is constrained in each isolated and individual point of any unit of work. And so if you then take that kind of architecture and use AI to build with it, the blast radius of building with AI is as small as those individual boxes that functionality goes into. And so that's more of like a top-down system design thinking thing where it's like, you literally can't mess this up, kind of. Whether that's a human developer who's just coming into the Clojure system and ecosystem, or like someone more experienced trying to build with AI. If you build with the right toolkit, then you're like limiting. You've enforced that your code can't like become spaghetti, basically.
And I should have said that going forth, I should probably use Eka instead of Claude Code, because I did watch the video on Eka, and that seemed really awesome.
Is that the Clojure NREPL?
Yeah, the ECA,
assistant?
the editor code assistant.
Oh yeah.
Yeah, wonderful. We have a few more moments, like 7 minutes to the official time. Maybe somebody who hasn't spoken wishes to say something or ask something before Cameron concludes this part. And then maybe some people will stay longer afterwards. Any comment, any thought by anybody? Oh yeah, thanks for sharing the Eka link. Yeah. Yeah, and I'm just want to say to our listeners, this call is a good example of what we wish to make more of, where companies can bring their stories and do that in a very useful, usable way of actually sharing some open source. That's the ideal, where some of what happens inside will be shared in the open in such a friendly way. So anybody who is listening, please be inspired by Cameron and the team, and do that as well. And yeah, since we have a few more minutes, maybe we should talk about the coming conferences in October. I'll share the screen just for a moment. Oh, thanks for those links. Yeah, later on when we share the meeting notes, we'll share those links.
I am working on Civitas too. I got with Timothy, so I'm working on. I think he even added Python support in the GitHub action for actually using libpython-clj for Civitas posts and stuff. So that was kind of a prereq for me. So I'm working on getting my demos into Civitas.
Fantastic. Yeah. So now when I'll share the screen, I'll actually begin with what Civitas is. All right. So Clojure Civitas is, I think you see my browser now. This is this new space where Clojurians can share their posts, which are actually Clojure namespaces rendered as notebooks with all kinds of stories, interactive visualizations, and so on. And our coming conferences will actually host posts in this space that was recently created by Timothy. And the idea is that whenever we have a conference, we'll also be able to kind of create a unified place where we share the notes, and the talk proposals are also posts to the Clojure Civitas space. And these are two of the coming conferences. A few other Clojure conferences are coming in around October, November, of course, but these two are organized by Scicloj, and these are the dates. Macro Expand Notch is about data science, data analytics, scientific computing, and so on. And Macro Expand Deep is about AI, composing language models, embeddings, and so on with other software systems, and also building them and interpreting and so on. There are a few great talk proposals in preparations, And still we are looking for more people to propose. And if anybody wishes to share any story or create something new or create a beginner-friendly tutorial or a new library or any other kind, let us chat. Let us, brainstorm together. And we like to help everybody in preparing the talk proposals. I'll stop sharing now. And if we have any thoughts about what would make these conferences useful for us, for you, then we can think about it. And if you have any thought about that, you can write to me anytime. Right. So we can make it as the space designed to help this community grow. And so, for example, we can have panel discussions, REPL sessions, interactive, more or less, and so on. And all kinds of teaching and exploration can happen there. So please let us be creative and make it our own space together. And yeah, any comments about that or about anything else before we stop the official part of this call? Oh, great. So maybe Cameron, you wish to conclude this part, say anything more before we say goodbye to the recording?
Sure. I guess I will just conclude by saying that I do feel like we're entering into a new era of sort of like the community becoming the steward of Clojure more and more. And I just hope that we keep doing things like this. And Daniel keeps doing Scicloj and everyone that helps with that. And that we have more people that just come together to create this kind of critical mass of Clojure sort of activity so that we can have it showing up where it matters and people see it as a viable option and that we can all, continue using Clojure into the future. So thanks for having me, and I long live Clojure, I suppose.
Yeah, thank you so much. Fantastic, great inspiration. And yeah, so you see all the nodding and applause. And so many thanks, Cameron. And we will now say goodbye to the recording and see you on the next time.